Next is density of states in 2 dimensions, quantum well. In quantum well, electron motion is confined along one direction. Let's say it is z directions. इलेक्ट्रॉन का मोशन रेस्ट्रिक्टेड है एक डायरेक्शंस में, उसमें मूव नहीं कर सकता. एंड इलेक्ट्रॉन कैन मूव फ्रीली इन एक्स वाई डायरेक्शन. सो इलेक्ट्रॉन एनर्जी इज क्वांटाइज्ड अलोंग वन डायरेक्शंस. लेट्स से E be the total energy and it is the sum of quantized energy along one directions, along z directions, and other two directions में energy is continuous along x y directions. Because हमने एक डायमेंशंस को रिड्यूस कर दिया है. We have to reduce one dimensions to a nanoscale. So we get जिस डायमेंशंस के अक्रॉस हमने रिड्यूस किया है बल्क को क्वांटम वेल में, उस डायरेक्शन के अक्रॉस हमें डिस्क्रीट एनर्जी मिलेगी. एंड जिनमें इलेक्ट्रॉन जिस डायरेक्शन के अलोंग इलेक्ट्रॉन फ्रीली मूव कर सकता है उनके अलोंग हमें कॉन्टिन्यूस एनर्जी मिलेगी. एंड जो एनर्जी की वैल्यू होगी दैट इज एच कट स्क्वेयर के जेड स्क्वेयर ओवर 2m प्लस एच कट स्क्वेयर के स्क्वेयर ओवर 2m, वेयर के इज के एक्स स्क्वेयर प्लस के वाई स्क्वेयर. Let's consider, because in 2D we have considered the circular area of in K space. Let's consider the circular area in K space of radius K. Let's say this is the circular area of K space in two dimensions. Let's say kx and ky, and area of this circle is pi k square, and where k square is kx square plus ky square. Here x and y are the directions along which particle can move. And consider a small area. Let's see kx and this is the length ky, and we have to divide into these axes as sub parts, and length of this sub part is kx is let's say 2 pi by lx, and ky is 2 pi over ly. और जो हमारा 2D मटीरियल है क्वांटम वेल, उसकी लेंथ है lx एंड हाइट है ly. सो वी डिवाइड दिस एक्सिस in sub intervals, sub parts of equal length, that is 2 pi by lx is the kx and 2 pi by ly is the ky. So kx ky represent a mode, okay. So let n1 be the number of modes in area AK, that is area of the circle over area of one mode, we got total number of modes. So area of circle is pi k square, area of one mode is kx, and ky represent a mode kx ky. After putting the value of kx ky we get 2 pi whole square lx and ly. So n1 be the number of modes, okay. टोटल नंबर ऑफ मोड इस एरिया में कितनी आएगी, दैट इज n1. एंड एक स्टेट में या एक मोड में वी हैव टू इलेक्ट्रॉनिक स्टेट. इन one mode we having 2 electrons and 2 electronic states. So because of Pauli principle, one electron with spin up can exist and one electron with spin down can exist together. So we have total number of electronic state is N2 is number of electronic states. States is 2 times N1, that is 2 pi k square Lx Ly over 4 pi square. After solving this, we got k square Lx Ly over 2 pi. Okay. So this is the number of electronic state is k square Lx Ly over 2 pi, and we have to find out density of state. dE is dN over dE, number of energy state, states per unit area, because in 2D we having area, per unit energy range, okay. So we have to find out dE, as N2 is k square 2 pi Lx and Ly, and N is number of electronic energy states per unit area, and area of the specimen is 2D में जो स्पेसिमेन है हमारा उसका एरिया होगा Lx Ly. So N is number of electronic state N2 over Lx Ly, that is k square over 2 pi, and we have to find out density of state. dE is dN over dE. From here we have to find out dN over dE is 1 over 2 pi 2k dk over dE, and from the energy and wave vector relation we having E is h cut square k square over 2m along free directions, along xy या free direction जो energy है, that is this. From here we have to find k, h cut square k square is 2me and k is 2me over h cut square under root, and dk over de is, we have only dk over de, so 2m over h cut square under root as it is half ek minus half. Okay, and let's say this is equation first. इक्वेशन का नाम कोई भी दे सकते हो तुम, ठीक है. And on putting the value of dk by de and k in this equation, 2 is cancel out. So density of state is k over pi dk over de, and from here value of k is 2me over h cut square and 1 by pi is here, and dk over de 2m by h cut square and half e minus half. After solving this we get 2 and 2 m over pi h cut square, pi h cut square. This equation represents density of states in 2D as number of energy state per unit area per unit energy range is independent of energy, और जो कर्व आएगा, ग्राफ आएगा, that is independent of energy. Let's say this is DE and it is a number and not dependent on energy. So this is constant. From here E is in this side and DE is in this side. Okay. So the value of density of state जो हमारी DEI है in XY plane, that is m over pi h cut square is associated with each value of kz. So it can be written as modified value of density of states, that is DE can be written as m over pi h cut square and summation of kz, because along kz direction we have some discrete value of energies h e minus ez. Okay, ekz. This is the ekz directions. Okay, where kz is index associated with confinement energy along, क्योंकि हमने एक डायरेक्शंस को कन्फाइन कर रखा है, उसके अलोंग जो एनर्जी है दैट इज डिस्क्रीट एनर्जी, और हमने जो डायरेक्शन ले रखी है दैट इज जेड डायरेक्शन. ओके, एंड एच ई माइनस ई के जेड इज हेविसाइड यूनिट स्टेप फंक्शन, एंड इसकी वैल्यू होती है एच ई माइनस ई के जेड, जो वैल्यू है 0 and 1 इफ E is less than E के जेड, एंड 1 होगी इफ E is greater than E के जेड. So